All right, this lesson is on evaluating polynomials. So evaluating a polynomial is really just like finding a value of the polynomial. So obviously we have to have a value that x equals. Like what is x that will give us a certain output for a total value of the polynomial. First, let's talk about function notation. With polynomials, function notation is when you put this, it's called f of x at the beginning, or it can be like g of x or h of x, basically that thing at the beginning. Now that's not a multiplication. It's not like f times x. F is not a variable in this case. It's just something that we use called function notation that's saying, here's the polynomial that represents this function. Okay, so usually it's going to be f of x, where the f is at the beginning. The only time where we use g of x or even h of x you see there is if you're using more than one function at a time. Now this function notation can be true for polynomial functions like these, or even linear functions, your y equals mx plus b equations. You could have f of x equals mx plus b instead. Okay, so it's just a way of writing your equations. Instead of saying y equals, we can say f of x equals. So let's take a look at evaluating. It's pretty basic, pretty straightforward. It's just a matter of keeping things straight, following PEMDAS, and double checking on a calculator if you need to. So for our first one, we have the polynomial right here. That's really what we're evaluating. 3x squared plus 5x minus 16. So 3 times the x value squared plus 5 times the x value minus 16. Yes, like I said, we have to follow the order of operations. Now, when we're given something like this, where it says f with 3 in parentheses, that's called f of 3. And what that means is we're trying to figure out what is the value of the function with the f when the x value is 3, because you'll notice in the parentheses was x, and in the parentheses now is 3. So all we're going to do is replace. All of the x's in that function become a 3. So everywhere we see an x, we replace it with 3. We maintain all of the operations, all the multiplications, all the exponents, all the additions, all the subtractions. All we're doing is substituting for now. From here, we follow PEMDAS. So parentheses first. Well, there's not really anything we can do inside the parentheses. So the next thing we would do is the exponents. And we actually have something with an exponent. It's just that part that I highlighted. It's just the 3 squared. Remember that means it's 3 times itself. So this is going to become 3 times 9 plus 5 times 3 minus 16. Then we can go ahead and multiply, because after parentheses and exponents is multiplication and division. So we actually have 2 multiplications. We have 3 times 9, and we have 5 times 3. Just go left to right. Well, 3 times 9 is 27. 5 times 3 is 15. So now we get 27 plus 15 minus 16. So adding and subtracting, you go left to right. So we add first in this case to get 42. And then finally we subtract 42 minus 16 is 26. So in the end it says f of 3 equals 26. And what that means is when I put x equals 3 into the polynomial, it gave me a value of 26. So evaluate means find the value of that function. So in our second example, we have f of negative 2. So we're using the same function, 3 times x squared plus 5x minus 16. The only thing that's different is we are going to change the value of x. Now we're going to use negative 2 as the value for x. So everywhere we see x, we're going to replace it with negative 2 on both sides. On the left-hand side over here, we don't really do anything with that. It's just f of negative 2 all the way to the bottom. But on the right-hand side, we have to follow PEMDAS. So we do exponents first. Keep in mind that when we do negative 2 squared, we have to remember that that is actually negative 2 times negative 2. It's a negative times itself, which is going to result in a positive number. So now we have 3 times 4 plus 5 times negative 2 minus 16. So next is my multiplication step. I can do both of those from left to right. 3 times 4 is 12. 5 times negative 2 is negative 10. And I bring down the minus 16. And we just work left to right. 12 plus negative 10 is 2. And 2 minus 16 is negative 14. So we end up with f of negative 2 has a value of negative 14. So when negative 2 got plugged in for x, I got negative 14 as the outcome. All right, last one, g of x. So again, it's just function notation. It's still just saying that the function of x is over here. It's 2 times x to the 4th power minus 3 times x minus 170. And they are telling us to find g of negative 3. In other words, we are going to take this function and we're going to replace anywhere we see an x with the number negative 3, because that's the number that is in the parentheses. Okay, so I'm going to put a negative 3 there, and I'm going to put a negative 3 there, in those two places where x was. Then we have to follow the order of operations when simplifying. So we do the exponent first. Okay, don't do 2 times negative 3 first. That's not how it works. I have to figure out what negative 3 to the 4th power is. You can use a calculator or you can use your head. Either way, you're multiplying negative 3 times negative 3 times negative 3 times negative 3, and you're going to get 81 when you do that. And it needs to be positive 81, because when you multiply 4 negative numbers together, you will get a positive answer. So I'm just going to bring down the rest of this for now and keep all my steps together. Next, I want to go ahead and multiply. I have two different multiplications here. 2 times 81 is 162. Now in the second step, I can look at it two different ways. I can either bring the subtraction down, and then I'm really only multiplying this. 3 times negative 3 is negative 9. Or I can look at it as negative 3 times negative 3 is positive 9. And either way, whether I write it as minus negative 9 or positive 9, it's going to simplify to be plus 9 there. And I bring down my minus 170 from the end. So now I go left to right, and I add first, because that's on the left. That's going to be 171 minus the 170 will leave us with just 1. So this function, when we substituted negative 3 for the variable, had an output or a value of 1. So g of negative 3 just equals 1.